Hi, in this video I'm going to discuss about another type of or another method for the non-parametric test. So in the last videos we discussed about the non-parametric test for one sample or two samples. If the population of those samples do not satisfy a certain distribution, especially if the population of the sample is not normally distributed, then we use the non-parametric test, right? We discussed about one sample, two sample with dependent pair and independent pair and all those type of cases. Now, so if there are more than two samples and if you want to know if the medians or central values in those samples are equal or not, then we use a test called Kruskal-Wallis test. Actually, in the next chapter, we will be studying the analysis of variance. What does that mean? That means we will be using like t-test or z-test type of thing for many samples, more than two samples, because in the last few videos we discussed about t-test for two sample, t-test for one sample, but we did not discuss if you are comparing more than two samples. For example, if you are comparing three samples or four samples or the population, then what method do we use? We haven't discussed that. Okay, we'll be discussing that later. But while we are doing the non-parametric test, I'm going to tell you how do we handle if there are more than two sample and if the distribution of the population of those sample are not normal, then how do we handle in this case, in more than two sample case, how do we handle that? Okay guys, all right, so let us read that. We call Kruskal-Wallis test for three or more samples. So Kruskal-Wallis test uses ranks of the data from three or more samples to test whether the samples came from population with same median. Note that ANOVA, we call analysis of variance, is used to test whether more than two populations have the same mean, but ANOVA requires that all of the population have normal distribution. Okay, if the population do not satisfy normality, we use Kruskal-Wallis test in case of the more than two samples. Kruskal-Wallis test require at least three independent samples and each sample has at least 5 observations. So sample size must be greater or equals to 5. As in the previous method, Kruskal-Wallis test uses combined ranks. You will combine the data and then you will rank them of all sample and find the sum of the all ranks in each sample. The test statistic is this. This is the test statistic formula. H equals 12 over n times n plus 1, where n is the sum of all sample sizes, because the first sample has size n1, second sample has size n2, third sample has size n3, and so on. So what is n? Uppercase N is the sum of those n1 plus n2 plus n3 and so on, where n is the total number of data points, k is the number of sample, number of groups, okay, Ri is the sum of ranks in each sample I, and Ni is the number of data in sample I. Okay, so what are the steps? So steps for the Kruskal-Wallis test for the independent samples. So H sub 0 is the sample came from population with same medians versus at least one of the sample population has different median. Okay, so combine all samples as a single data set and rank them from smallest to the largest. Second one is find the sum of the ranks R sub I of sample I. Also find the sample sizes n sub I. Okay, and next one is find the test statistic H using the above formula, that formula there, and then n equals to the summation of n sub I. Okay, so what we do is you find out the R sub I. What is R sub 1? Is the sum of the ranks in the sample 1. R sub 2 is the sum of the rank in the sample 2 and so on. And you find out n is summation of ni, meaning all the data points. So sum of the data points in all, so sum of the number of data points in all sample, and then find out h using that formula there. Okay, and next is to find the critical value using the right tail chi-square table. To find out the critical value, you use q chi-square, but the thing is, if you want to use the p-value method, then you use p chi-square. Okay, all right, so where alpha is the given area, and then the last step is if the test statistic fall in the critical region, then reject the H0. Or if you want to use the p-value method, find the area right of H, because it's the right tail test. So if p is less than alpha, you reject, otherwise do not reject. Let us see this example. The following data is the measurement of serum cotinine, a chemical that is produced after nicotine is absorbed, in 3 groups of people: smokers, non-smokers but exposed to environmental tobacco smoke, and non-smokers not exposed to the environmental tobacco smoke. So these are the cotinine level of the smoker. These are for the non-smoker, but they are exposed to the environmental cotinine level smokers, or they are, you can say that these are exposed to the smokers. Okay, and then these are non-smokers and not exposed to the smokers. These are the cotinine level. Basically, they do not have any cotinine level in their body. Okay, now, so if the samples are randomly selected and alpha equals to 0.05, test whether the 3 populations have cotinine level with the same median or not. That's what you want to do. Okay, all right. So write H0 and H1. H0 is they have the same cotinine level, and H1 is they do not have the same cotinine level. Okay, now you need to rank the data. So I have done all these steps in R. See, so I copied that X, Y, and G. So that's X, Y, and Z. Oh, by the way, what it says here is, I think I need to remove, because it looks like it is remembering the things from the previous one. So let me do remove X, remove Y, and remove Z. Okay, so let us do that. All right, now I denote X. I copied that X data, Y data, and Z data, and then I just ran those. Now what I'm doing here is I'm giving a name data, and then I'm combining these 3 data set into a single row, okay, so that it is easy to rank. Because when you rank in the Kruskal-Wallis test, you need to mix all those data set together, combine all them together, and then rank as a one group. Okay, so I did the data is that all those combine in one sample, and then R equals to rank. I ranked all those. If you want to see how does that R look like, so this is what the R look like. Okay, these are the rank of this data set. Okay, you see that all those are 0, so they are getting 5.5 rank, right? All of them are getting 0, so all these zeros are getting 5.5. There is one more 0 there. Okay, all right, now you know how to rank them. We have done those already. So n1 is the length of X, n2 is the length of Y. How many data sets are there? How many data sets are there? How many data sets are there? Those are the n1, n2, and n3. And uppercase N is the sum of those, meaning the total number of data set will be the. So all right, so what is the R1? R1 is the sum of ranks on the first column, right? So what are the ranks on the first sample? So what are the ranks in the first sample? There are 5 data points, 1, 2, 3, 4, 5. These are the ranks for the first, the very first sample. If you add them, you will get, let me see what we get. We get R1 is 65. Similarly, you add the ranks on for the second sample and ranks for the third sample. We got 67.5 and 38.5. That's what you get. Okay, now we find out H. What is the formula for H? Formula for H is 12 over n times n plus 1, and R1 square over n1 plus R2 square over n2 plus R3 square over n3, because there are 3 samples, and then minus 3 times n plus 1. That's what we get. So if you run this, you get H equals to 6.72. 6.724. You see that? This is the value of H. This is the, what is that? That is the test value, right? Now to find out the p-value, this is the right tail test, right tail chi-square test. So to find out the p-value, what you do is you need to do 1 minus p chi is H. And what is the degrees of freedom? So the degrees of freedom is equals to 2 here. Why? Because there are 3 samples. Okay, so this is number of sample, number of, you can say groups or sample minus 1. Okay, so there were 3 samples, 1 sample, 2 sample, 3 samples, and then minus 1 is 2. So you do that, and we found that the p-value is 0.0346, which is less than alpha. So we reject the null hypothesis, meaning that the cotinine level, the median coordinate level on these three groups of people are not the same. Okay, that's what we can see. But if you want to do directly from R, you can do Kruskal-Test and list X, Y, Z. You see that? It has 3 data sets, so you need to write list and then name of those data set. If you do this, you will get the p-value is 0.0173 using R, okay, which is less than alpha. So that means that you reject the null hypothesis. Now, if you want to see the box plot of that, you see that, look at this box plot. Okay, in the box plot you see that the median on these 3 groups, the first group is X, second is Y, and third is Z, are like significantly different. You see that from the second and third it looks like they are almost equal, right? But on the first, compared to the first, it is a lot high. So meaning that we have the different median values of the coordinate level. So you can use the Kruskal-Wallis test if you are comparing the population if the population do not follow the normality assumption, okay, and if you are comparing the more than 2 populations. Okay guys, thank you.